Hey everybody, so today we're going to be learning about the chain rule, which is one of the rules that we have for derivatives. And I know it may have been a little while since we've done some of this stuff, so I did want to sort of remind us really briefly of things that we do know how to take the derivative of and things that we don't know how to take the derivative of. So over on this side, I've sort of made us a quick list of things that we do know how to take the derivative of. We know how to take the derivative of constants. We know how to take the derivative of powers. Like we know that the derivative of like x cubed would be 3x squared. We know that we bring that power down, and then decrease the power by 1. We know that we have a constant multiple rule. The constant multiple rule is the one that tells us that, when you're taking the derivative of this thing multiplied by a constant, you could ignore the constant, do the derivative, and then put the constant back on. And we have our addition and subtraction rule that basically tells us that if you add or subtract two things, you can just take the derivative of those two things individually. Now, when we learned about derivatives before, I also reminded you that there were a bunch of rules that we don't have. Notably, we don't have any other rules. We don't have a product rule. We don't have a division rule. We certainly don't have this thing called the chain rule. But the chain rule is what we're going to talk about today. And the chain rule is all about how we take the derivative of compositions of functions. But you may have forgotten what composition of functions is, so we're going to go over that really briefly before we actually get into the chain rule. So here we go. As an example, imagine that we consider these two functions. We have the function e to the x, and we have the function 5x minus 3. Composition is basically where you do f of g of x, and when you do g of f of x. My bet is that most of you guys already know how to do those things, but pause the video real quick. Make sure that you're able to find f of g of x and g of f of x, and then I'll explain how to do them just in case you need that explanation. So the first one, f of g of x, really just means that we're going to take this inside function g of x, and we're going to plug it in wherever we see an x in the f function. So when I do f of g of x, it means I'm going to take the f function up here, and I'm going to do e to the, but not x, I'm supposed to plug g of x in, so it'll be e to the 5x minus 3. Okay, that's what f of g of x is. Similarly, when I do g of f of x, okay, in this one I'm going to take the g function, and wherever I see this x, I'm going to plug in the f of x function. So g of f of x is just going to be 5 times e to the x minus 3. Okay? Now I think the thing that I want to point out here is that one of these functions we can take the derivative of, and one of them we don't know how to take the derivative of. And so I would encourage you actually to pause the video and think for a moment about which of these can you take the derivative of, which of them can you not, and why can you not take that derivative. So the one of these that we can take the derivative of is we can take the derivative of this function over here. Right? All this would require is it would require the constant multiple rule for this, because I have a constant 5 times the function e to the x that I know how to do the derivative of, and then I need the subtraction rule that lets me say, hey, I can do the derivative of this because it's just two things subtracted. Okay? We know that the derivative of this would be 5e to the x minus 0, in other words, 5e to the x. Okay? On the other hand, this one over here, we actually don't know how to do the derivative of this one, because we've never dealt with how to do the derivative when something is plugged in, how to do the derivative of something that's been composed with another function. And that's really what the chain rule is all about. So the rest of this video is really just going to be us learning about the chain rule and doing some examples of it. So what I've done here is I've expressed the chain rule in two ways. I've expressed it mathematically, and then I kind of expressed it in English. Okay? So what the chain rule says is it says if you have a function which is a composition, which is g of x composed inside of f, to do the derivative, you'll do the derivative of the outer function and leave the composed inside function alone. Leave it in there. Then you'll multiply by the derivative of that inside function that you ignored. Okay? And honestly, that I literally I didn't read this, but I sort of said that exact thing. Okay, so again, for the chain rule, what's really happening is you're doing the derivative of this outer function, leaving the inside thing plugged in, and then multiplying by the derivative of that inside piece. Okay, now I will repeat this to you. This sounds confusing, but it becomes much more clearer. I'm sorry, that's really frustrating. It becomes much more clear with examples. Please pardon my typo there. Oh well, it is what it is. So let's get into some of those examples that'll make this so much more clearer. Here we go. All right. In this first example, I'm going to go through a couple of steps along the way to sort of help you see what these steps are, and then in the other ones, we're going to take some of those supports away, okay? So for this example here, I'm giving us the function sine of x squared and asking you to find the derivative, okay? So the first question I would ask is, what is the outer function here? Okay, and if you'd like to pause the video for a moment and do these for yourself before I talk about them, please do that now. But here we go. The outer function for this is going to be the function sine x. Now, you might have said that the outer function was sine, but sine alone isn't a function. Saying sine alone is like saying square root, or squared, or natural log. All of these things need an x in order for us to have a function for them. So the outer function here is sine x, and the inner function, the thing being plugged into it, is x squared. So you can see that this sine of x squared comes out of us taking the sine x function with x squared plugged into it. Okay? Now the next step is for us to identify, okay, so what is the derivative of this outer function? Well, the derivative of sine is cosine, and the derivative of the inner function is 2x. Okay? Now, according to our chain rule, the chain rule tells us that we're supposed to take the derivative of the outer function with the inner function plugged into it, then multiply by the derivative of that inner function. So if f of x is the sine of x squared, then the derivative will be the derivative of the outer function with the inner function left alone times the derivative of that inner function that we just ignored. And if it was me, I would probably clean this up and write this as 2x times the cosine of x squared. Okay? And like that's it. This is the chain rule. This is the whole thing. And at this point, we unlock the ability to do derivatives of so many other functions. So now we've got like 5 examples on the next page. If you feel really good about these, maybe try the next couple of them on your own and then watch the video and check and make sure you got them right. If you're feeling kind of shaky, sort of follow with me as we go through the next ones. So let's look at them. All right, so my first one here, I've got this function e to the 7x minus 4, and I'm being asked to find the derivative of that thing. Okay, so for those of you that might want a little bit more supports on this one, you might start by identifying what is the outer function and what is the inner function that's being plugged into that. Okay, so the outer function is the function e to the x, and the inner function that's being plugged into that is 7x minus 4. Okay, then we remember from the previous problem that we would take the derivatives of these things, right? The derivative of e to the x is, it's everybody's favorite derivative, that's e to the x. And the derivative of 7x minus 4 is just 7. Okay, so when I go to do the derivative, g prime of x, I'm supposed to do the derivative of the outer function with the inner function left in it, so e to the 7x minus 4 times the derivative of the inner function, so times 7. And again, I would probably beautify this a bit by putting the constant in the front. It's kind of a standard way of writing this. Okay. So that's our derivative for this one. The derivative of e to the 7x minus 4 is 7 times e to the 7x minus 4. Here's our next example. Right? We've got our function h of x, which is the natural log of 3x squared minus 5x plus 4. Hopefully you can see here that this is really clearly a composition. Right? There is an outer function, natural log x, and there's an inner function, 3x squared minus 5x plus 4. Okay? I'm going to do one more of these where I sort of do this with the supports. We see that the outer function here is the natural log of x, and we see that our inner function is 3x squared minus 5x plus 4. Okay? Just like we did in the previous one, we'll take the derivative of the outer function. Think from what the derivative of natural log of x is 1 over x. And the derivative of our inner function is 6x minus 5. So when I go to do h prime of x, I'm supposed to do the derivative of the outer function with the inner function left plugged into it. So 1 over 3x squared minus 5x plus 4 times the derivative of the inner function, the thing before that I just ignored and didn't do the derivative of. So times 6x minus 5. And as I've been doing with the other ones, I'll take a moment to beautify this a bit. 6x minus 5 over 3x squared minus 5x plus 4. Okay? I've got a couple more examples here that we can do, just again to give you guys the opportunity to do these. If at this point you're feeling really good about these, you feel like you've got the idea, please try and do the next one on your own. This really is kind of your opportunity to practice these things and make sure that you're getting them. All right, so here we have f of x being the cosine of the square root of x plus 11. I think I'm going to keep writing the outer and the inner thing. It'll make the video a little bit longer, but you guys can just fast forward this if you don't need to see it. Our outer function here is cosine x. My inner function is the square root of x plus 11. The derivative of cosine is negative sine x. The derivative of this one, like you guys might not feel comfortable just doing this derivative right away. You might want to take a moment to rewrite this as x to the 1/2 plus 11. And then remember that this would be 1/2 x to the negative 1/2 plus 0, which we could rewrite as 1 over 2 root x. So sometimes, especially if you're getting back into the groove on doing these derivatives, it might take you a little while to figure some of these things out. But once you know the outer function and the inner function, and you know the derivative of the outer function, the derivative of the inner function, we can use the chain rule to put it all together. So the derivative of this thing would be the derivative of the outer function, negative sine of, leave the inner function alone, the square root of x plus 11, times the derivative of that inside piece that we ignored. Like I've been doing on the other ones, we'll take a moment here to make this a little bit prettier. I would put the sine of the square root of x plus 11 on the top and the 2 root x in the denominator. Okay, we've got 2 examples left, 2 more things for you guys to try. So here I have g of x being 5x minus 7 to the 10th power. This is a really, in a lot of ways, a really, really simple problem because it's like the outer function here is x to the 10th power, and the inner function is 5x minus 7. So just kind of to give you guys an idea for what it looks like to do these problems once you really get the hang of it, the derivative of this problem, g prime of x, would be, well, I know the derivative of a 10th power is supposed to be 10x to the 9th power. But the chain rule tells me to leave the inside alone and then multiply by the derivative of that thing that was inside that I just left alone. So I hope you guys can sort of see in this example that it's really not necessary that you guys write down outer, inner, derivative of the outer, derivative of the inner. As you guys get better and faster doing these derivatives, you'll be able to do these chain rule derivatives really quickly too. I hope you already did the delta math practice and worked through some of those. But the same way that we're going to work on speed and multiplication, speed and powers, I want us to work in speed and derivatives too. I want this to be stuff that you guys are fluent with. The thing I would do here to beautify this would be to put the 5 and the 10 together and make this 50 times 5x minus 7 all to the 9th power. All right, so we'll now go on to our last example. All right, so in this one, we've got our outer function. Our outer function is the square root of x. Our inner function is 6x squared minus 5. The derivative of this outer function, I'm going to sort of skip a couple of steps here because we did this earlier. The derivative of the square root of x is 1 over 2 root x. That actually might be one that you guys work on committing to memory. Like maybe the square root of x you stop thinking of, like at some point it would be great if we stopped doing the step of x to the 1/2, then 1/2 x to the negative 1/2, then changing it into this thing. If we can memorize that this is where this derivative goes, we can save ourselves some time later. If you're not ready for that today, no worries, but I just wanted to throw it out there. The derivative of our inner function here is 12x. And then so as we've seen, I don't know, like 6 times now, the derivative of this thing will be the derivative of the outer function, so 1 over 2 root with the inner function left in it, 6x squared minus 5 times the derivative of the inner function, so 12x. Okay, so I'm seeing here now that the 12 and the 2 are going to reduce down to a 6, and so in the end I would write this as 6x over the square root of 6x squared minus 5. Okay. This is the chain rule. Like we've gone through a number of examples of this now, so I hope you've got the hang of it. We'll practice more of these as this week goes on, and the chain rule is not going anywhere. We're going to spend a lot of time with the chain rule, and it's going to get combined with other rules. So like our next step is really to sort of practice the chain rule and really get good at this and feel comfortable with it before we move somewhere else. So I hope that helped, and I'll see you guys soon.